When assigning peaks in top-down protein spectra, mass accuracy is very important. So in this video, I'll show you the two main ways to recalibrate your data in AutoSeequer. This is the AutoSeequer main user interface. And for this example, we'll process the same myoglobin data that we've used for all the other training videos. As you can see from the sequence map, currently I've set AutoSeequer to look only for the C' and Z dot fragments, as these are the main fragment types seen in this spectrum. Up at the top here, you can see that I've been searching for assignments across a plus or minus 60 ppm range. And down here in the Mass Errors tab, you can see the mass errors associated with these assignments. The data in this file hasn't yet been recalibrated, and so that's why we can see that the main set of assignments follows this very specific trend across the master charge versus mass error plot. And it's this trend that we intend to correct for in the mass recalibration. There are two different ways of undertaking a mass recalibration in AutoSeequer, and in this demonstration I'll show you how to use both of them. If I was processing this spectrum, I would use the first of these methods to undertake a quick recalibration of the data using the cursors that you can see here on the mass error plot. The number of cursors you see on the plot will depend on the order of the recalibration function. Here you can see that it's set to 2, and so that requires 3 cursors. If you need to use a higher order recalibration function, you simply change the number on this control and the number of cursors will automatically update. To perform a quick recalibration, simply drag the cursors to define the recalibration curve you want, and once you're happy with the general fit of the line, click the Use Quick Recalibration button to recalibrate the data. And you can see that that simple process has got rid of the majority of the mass calibration function error. My next step would then be to reassign the data using a much narrower error range, say plus or minus 10 ppm. Using these assignments, we can perform a more conventional kind of mass recalibration. And to do this, we need to jump to the AutoCal tab. These two columns will be filled with all of the current assignments. And you can choose to keep those that you wish as recalibration points for this second style of internal recalibration. Or you could delete all of the contents and replace them with a consistent set of recalibration fragments that you're using across multiple files. For this example, we'll delete all of the Z fragments and recalibrate the data only on the C' fragments. So to do that, we just double-click in the reverse calibration ions box and hit delete on the keyboard. This will cause the recalibration function to be recalculated based only on the C ions. And once we're happy with that, we can click the Accept button to apply it to the whole dataset. And now the data is really well internally recalibrated, we can reassign it again over an even narrower mass error range, say plus or minus 2 ppm. Up to this point, we've been using only the 2 main ion series to recalibrate the data. Now, to test the appropriateness of that recalibration, let's search for all the other fragment classes that we might expect to see in this dataset, and then we can see if those fragments also align well with those of the main ion series. You can easily change the types of ions you're assigning by clicking on the controls in the Frag Classes to Search tab. So now let's look at the mass errors of those assignments. What we're looking to see is if the fragment classes we've just assigned have the same statistical profile for their mass errors as the originally assigned series. Here on the mass errors by mass plot, the data looks good, but we should also check on the plot that shows the mass error as a function of the signal to noise ratio of the peaks, and we access that by clicking this tab. The results on this tab show that the assignments we've made seem to have only one error distribution, and so that might indicate that the mass recalibration is possibly correct. And so to summarize, the two main ways of undertaking a recalibration in AutoSeequer are the quick recalibration using the cursors on the mass error tab, and the more formal internal recalibration using a subset of the top-down fragments that you can undertake using the AutoCalibration function on the AutoCal tab. Whichever way you undertake the recalibration, the parameters of that recalibration curve will be saved in the assignments file when the data is exported. If you want more help with recalibration in AutoSeequer, please contact either the SpectraSwiss team or kilgourlab.com directly. Thanks for listening and happy processing.